let's have more examples on how to simplify rational algebraic expression. Okay, let's have here number 1. You have here x squared plus x minus 42 all over x squared minus 36. Okay, as you observe, the numerator is a trinomial. So, definitely, we could use factoring trinomial. So, if you have your trinomial, so meaning expected that you have two binomial factors for x squared plus x minus 42. Okay, so factor first the first term, x squared. So factors are 2x. Then negative 42, you factor this so that you could get the middle term, x. So by doing so, you could have here positive 7 minus and negative 6 rather. So if we're going to check this, 7 times x, it would be 7x. X times negative 6, that is negative 6x. So you add them, 7x plus negative 6x, definitely you could get positive x, that is the middle term. So the factors x plus 7 times the quantity x minus 6, they are the factors of x squared plus x minus 42. Okay, how about the denominator? So you have your x squared minus 36. So as you observe, x squared and 36 are both perfect squares. So definitely we're going to use here the difference of two squares. So to use that, express each term to the power of 2. So you have x squared minus 6 squared. So you have your x plus 7 times the quantity of x minus 6 over, so you factor that, it's very easy. So you have your x from here, the base is x. Okay, and for 6 squared, just pick their base, the base which is 6, so plus 6 minus 6. So as observed, numerator and denominator already have common factor, which is the binomial x minus 6. So you cancel that out. Okay, by the way, canceling that does not mean you eliminate it or it's equal to 0, not. But definitely what happens here is x minus 6 divided by x minus 6, that is 1. So you just multiply that to x plus 7 over x plus 6. It cannot affect the given or the remaining expression. So simplify that. That would be x plus 7 over x plus 6. Okay, that is the simplified form of x squared plus x minus 42 all over x squared minus 36. Now, let's have second example. You have here 2x minus 1 over 1 minus 2x. Okay. So here, class, both numerator and denominator are binomials. But, so first thing you do is you look for the GCMF. 2x and 1, you have no GCF. The same with 1 and 2x. But notice, class, for numerator, you have 2x here. For denominator is 2x also. But they differ with sign. The same with 1. They differ with sign. So, definitely, you're going to factor negative 1 as considered as the GCMF. So, let's try. 2x, we consider here, why is it I factor negative 1? In order to get 1 minus 2x. Okay, let's do that. Okay. That would be 2x divided by negative 1. Okay, let's change color. And then minus 1 over. the same thing, divide by negative 1. So the denominator, just copy that, 1 minus 2x equals, so negative 1, 2x divided by negative 1, that is negative 2x. And then you have here minus, we can consider it as negative. Negative divided by negative, that is positive. So plus 1. Then 1 minus 2x. Okay, so this negative 2x plus 1, you can arrange that. That could be 1 minus 2x. Okay. And then over 1 minus 2x. So as you observe, they have common binomial factor, which is 1 minus 2x. So, cancel that out. So, remaining is negative 1. Okay, class. You can also do this. Okay, I will give you another scenario. So, 2x minus 1 over 1 minus 2x. So, above, class, you factor negative 1 for numerator. How about to factor negative 1 for denominator? Okay, let's do that. So, 1 divided by negative 1 minus 2x divided by negative 1. Okay, since our goal for denominator to get a 2x minus 1, so just copy. Okay, so copy only for numerator. Okay, so you have negative 1. 1 divided by negative 1 is negative 1. Negative divided by negative, that is positive. So, plus 2x. So, that would be 2x minus 1 over negative 1. So, rearrange that. That becomes 2x minus 1. Okay. So, you come up with common monomial factor. I mean common binomial factor, which is 2x minus 1. Okay, so, hey, ma'am, 2x minus 1 here is cancelled out already. So, is that mean the numerator, the remaining number there is 0? No. Definitely there is 1. Why? Since 2x minus 1 divided by 2x minus 1, that is 1. Over this negative 1. 1 divided by negative 1, that is negative 1. So, as you can see, class, you have the same answer. Okay? Okay, now let's try another example. (64x cubed minus 1 over 12x squared plus 13x minus 4. So for this, 64x cubed minus 1, so there is no GCMF. So proceed, it's either the other techniques, factoring techniques. So since there are two terms, it might be the sum or difference of two cubes or the difference of two squares. But you may check it. 64x cubed is a perfect cube and also with 1. So definitely 64x cubed minus 1 is, you can apply factoring technique for the difference of two cubes. So how? Okay. Let's write other. Okay. To visualize the correct solution. Okay, to do that, express first each term to the base of 3. I mean to the power of 3. So 64x cubed, that would be 4x quantity cubed. then minus 1 cubed. So you already express each term to the power of 3. Okay. How about the denominator? 12x squared plus 13x minus 4. So as you observe, there is no GCMF. So you proceed with, since there are 3 terms, so you could use factoring trinomial. So as expected, you have 2 binomial factors. So this is kind of tricky because the numerical coefficient for first term, 12x squared, is 12. The last term also is negative 4. So actually, there are many combinations. There are many options. But you stick with the focus that you could get the middle term, which is 13x. So let's try. If you have 12, that would be 12x squared. That would be 12x times x. If you have 4, negative 4, it would be negative 4 times 1. Okay. If you combine that, 12x times 1 is 12x. Then can you add this? Negative 4 times x is negative 4x. If you add them, that would be 8x. So you cannot get 13x. How about the other combinations? Okay, how about using 412 6x times 2x. And for negative 4, your goal is 13. If you're going to partner, so yeah, you could have negative 4 times 1. Plus, if you're going to multiply this 2, it would be negative 24. That's very far. Your goal is 13x. How about 6 times 1, and then it was 6. Then negative 4 times 2x is still negative 8. It's very far. Okay, let's try another combination. How about this? 4x times 3x. And for negative 4, it would be negative, okay, Joseph, positive 4. Okay. Positive 4 times negative 1. I guess we could get the answer. So you have a 4x and then 3x. And for 4, we will partner this with 4 because that will resolve to 16. So here we're going to put here 4. Okay, and then put here negative 1. If we're going to check that class, negative 1 times 3x is negative 3x. 4x times 4, that is 16x. So if we add that, 16x plus negative 3x, that results to 13x. Okay, that's correct. Okay, so that they are the factors. Okay, let's continue. Okay, applying the factoring of difference of 2 cubes. So get their base. So you have 4x minus 1. Okay, from the binomial factor, you get the trinomial factor. How? Square of 4x, that would be 4x squared. Okay, we'll use bracket. Okay, and then you multiply the 2. So since negative, it would be, we'll place here positive, the partner for negative here. It's a pattern for the difference of 2 cubes. 4x times 1, that is 4x. And then square of 1. Okay. Okay, now copy 4x 1 minus 1, 3x plus 4. Okay. So Continue. 4x minus 1. Okay, square of 4x is 16x squared. Plus 4x, square of 1, that is 1. Over 4x minus 1 times 3x plus 4. So as you observe, class, they have common binomial factor, which is 4x minus 1. So you cancel that out. Okay, so meaning 16x squared plus 4x plus 1 over 3x plus 4 is the simplified form of 64x cubed minus 1 all over 12x squared plus 13x minus 4. Okay, I hope you learned about how to simplify rational algebraic expressions. See you soon. God bless.